The majestic Himalayas, a testament to Earth's power. The Himalayas, with their snow-capped peaks piercing the sky, are a breathtaking testament to the immense power of our planet's tectonic plates. These majestic mountains, home to the highest peaks on Earth, were not always a part of Asia. They stand as a magnificent reminder of the incredible journey that the Indian subcontinent undertook millions of years ago. A journey that culminated in a colossal collision that reshaped the very face of our planet. For centuries, the Himalayas have captivated the imagination of explorers, scientists, and dreamers alike. Their towering heights and rugged beauty speak to a power that is both awe-inspiring and humbling. But these mountains are more than just a pretty sight. They are a living laboratory, offering us a glimpse into the dynamic forces that have shaped our planet over millions of years. The Himalayas are a relatively young mountain range, geologically speaking. They were formed as a result of the ongoing collision between the Indian and Eurasian tectonic plates, a process that began around 50 million years ago and continues to this day. This collision is what geologists refer to as a continental collision, a slow-motion car crash of unimaginable scale. As the Indian plate continues to push northward into the Eurasian plate, the land is forced upwards, creating the towering peaks of the Himalayas. This process, known as uplift, is ongoing and is the reason why the Himalayas continue to grow taller, albeit at a rate of just a few millimeters per year. India's long voyage from Gondwana to isolation. To understand the formation of the Himalayas, we need to rewind the clock hundreds of millions of years, back to a time when the Earth's continents were arranged in a vastly different configuration. Back then, India was not a part of Asia, but was instead fused with Africa, Australia, Antarctica, and South America in a supercontinent known as Gondwana. Around 200 million years ago, Gondwana began to break apart, driven by the relentless forces of plate tectonics. The Earth's crust is not a single solid shell, but is instead broken up into numerous pieces like a giant jigsaw puzzle. These pieces, known as tectonic plates, are constantly on the move, albeit at a snail's pace, driven by the heat emanating from the Earth's core. As Gondwana fragmented, India embarked on an epic journey northward, drifting across the ancient Tethys Ocean at speeds that, while seemingly slow by human standards, were remarkably fast in geological terms. This journey would last for millions of years and would see India travel thousands of kilometers, leaving its former Gondwanan companions far behind. The Collision Unveiled, a two-act geological drama. For many years, scientists believed that India's collision with Asia was a singular event that occurred around 50 million years ago. However, recent research utilizing cutting-edge techniques like isotopic analysis has revealed a more nuanced and intriguing story. It turns out that India's rendezvous with Asia was not a single collision, but rather a two-act geological drama that unfolded over millions of years. The first act of this collision began around 50 million years ago, not with the Eurasian continent itself, but with a string of islands that lay scattered across the ancient Tethys Ocean. These islands, remnants of the ancient supercontinent Gondwana, were the first to feel the embrace of the approaching Indian subcontinent. This initial collision, while significant, was but a prelude to the main event. Around 40 million years ago, India finally made contact with the southern edge of the Eurasian plate. This marked the beginning of the second and most dramatic act of the collision, a slow-motion collision that continues to this day. Section 4. Rethinking Greater India. Shrinking continents and shifting timelines. The revised timeline of India's collision with Asia has had profound implications for our understanding of the Indian subcontinent's geological history. One of the most significant of these implications has been a re-evaluation of the concept of Greater India. Prior to the discovery of the two-stage collision, geologists had envisioned a much larger Indian plate, extending far beyond its present-day boundaries. This Greater India was thought to have been subducted or forced beneath the Eurasian plate during the collision, explaining the vast distances India had seemingly traveled. However, the revised timeline, pushing back the final collision by 10 million years, challenges this notion. A later collision implies a shorter distance traveled by the Indian plate, meaning that Greater India may have been significantly smaller than previously thought. Section 5. Isotopic clues, unraveling the mysteries of deep time. The revised timeline of India's collision with Asia was not based on mere speculation, but was the result of meticulous research utilizing cutting-edge geological techniques, particularly isotopic analysis. This technique allows geologists to peer back in time, unraveling the history of rocks and the tectonic plates they're a part of. Isotopes are atoms of the same element that have the same number of protons but a different number of neutrons. This difference in neutrons gives isotopes slightly different properties, which geologists can exploit to determine the age of rocks and to trace their origins. In the case of the India-Asia collision, geologists focused on a region in the northwestern Himalayas known as the Kohistan-Ladakh Arc. This region is home to rocks that were once part of the ancient Tethys ocean floor, now uplifted and exposed by the ongoing collision. By analyzing the isotopic signatures of these rocks, geologists were able to determine their age and, more importantly, the timing of their uplift. This data provided crucial evidence for the two-stage collision model, revealing that the initial collision with the island arc occurred around 50 million years ago, followed by the main collision with Eurasia 10 million years later. Section 6. The Himalayas today, a living laboratory of geological processes. The Himalayas are not a static feature of our planet, but are instead a dynamic and ever-evolving mountain range shaped by the ongoing collision between the Indian and Eurasian plates. This ongoing collision continues to have a profound impact on the geology, climate, and ecosystems of the region. As the Indian plate continues to push northward, the Himalayas continue to rise, albeit at a rate of just a few millimeters per year. This uplift is not uniform, however, and varies across the mountain range, leading to the formation of towering peaks, deep valleys, and vast plateaus. The Himalayas also play a crucial role in shaping the climate of the Indian subcontinent and surrounding regions. The towering peaks act as a barrier, blocking cold, dry air from the north and trapping warm, moist air from the south. This results in a stark climatic divide, with lush rainforests flourishing on the southern slopes of the Himalayas and arid deserts stretching out to the north. Section 7. Conclusion. The ever-evolving story of India's tectonic journey. The story of India's collision with Asia is a testament to the immense power of plate tectonics and the ever-changing nature of our planet. What was once an isolated island adrift on the ancient Tethys Ocean is now a part of the largest landmass on Earth, forever joined with Asia in a geological embrace that continues to shape the landscape and ecosystems of the region. The discovery of the two-stage collision model, made possible by advances in geological dating techniques like isotopic analysis, has revolutionized our understanding of this monumental event. It has forced us to rethink our assumptions about the size and movement of ancient continents and has highlighted the complex and often unexpected ways in which Earth's tectonic plates interact. The Himalayas, standing as a majestic reminder of this ancient collision, continue to captivate and inspire us. They are a living laboratory, offering us a glimpse into the dynamic forces that have shaped our planet over millions of years and continue to do so today. As our understanding of plate tectonics and geological processes continues to evolve, so too will our appreciation for the incredible journey of the Indian subcontinent and the majestic mountain range it helped create.